to do Chapter 11, Physical and Chemical Control of Microbes, because without adequately knowing how to control microbes in the way they need to be controlled, they would just overrun. So first we'll kind of get into the different ways we control these microbes. These are through means of sterilization, disinfection, antisepsis, and decontamination. And we'll kind of get a little bit into those in the next slides and go over which ones are which. So first we have sterilization. And we know that this means that all microbial life is destroyed or eliminated. Sterilization takes care of everything. It's commonly used in medical facilities. We know hospitals, we do a lot of sterilization so that we don't pack different germs and microbes and stuff to the next patient. There are three main types of sterilization, and that's steam, dry heat, and ethylene oxide. So steam sterilization uses temperatures that range from 121 degrees Celsius to 132 degrees Celsius. Dry heat is typically what we use for the glassware, the oils, the powders, and the temperatures in this range anywhere from 160 to 170 degrees Celsius. Ethylene oxide is a safer, because it's tightly controlled. It ensures safe surgeries and medical treatments. So like I said, a lot of sterilization goes on in the hospital. Next, we'll talk about disinfection. Now, disinfection is where we're destroying or inactivating those microorganisms on the surfaces. So you take Lysol and you spray your countertops. That is a mean of disinfection. Like I have here, we commonly use disinfection in everyday life. Some examples are bleach and alcohol solutions. I know I mop my floors in bleach to help disinfect them. There are three levels of disinfection, and there's high, intermediate, and low. So those high levels are for things that come in contact with mucous membranes, and the low is for things that'll come in contact with your skin. And intermediate is kind of between those two. Next, we'll kind of talk about antisepsis. So this is applied to living tissue to stop or slow down the growth of microorganisms. And some examples of this are chlorhexidine, peroxide, and alcohol. So these are things that we can put on our skin without harming us. Peroxide, you may have cut your finger, and we know that we can put peroxide on there, and it helps kind of clean that wound. We do alcohol also. It just burns, as we all know. Chlorhexidine, I've seen it used in the hospital. We've cleaned around ports with that. You can use this to clean any cut, wound, abrasion, burn, or bite. Like I said, it's used in the home, and we do use it in medical settings, but you'll definitely use it in your home a lot. Joseph Lister was actually the man that established the study for antisepsis. Next, we'll talk about decontamination. So, kind of sounds like the same, as disinfection, but different. It is the process of removing contaminants on an object or area. This can include chemicals, microorganisms, or radioactive substances. There's a couple of different methods they use when they're decontaminating something. It can be physical cleaning down to washing something, to autoclaving, and if you've never seen an autoclave, um, I've seen them in the OR. There's certain utensils, medical devices they use that they will autoclave so that they are free of everything for the next time they need it for their next surgery. Um, there's a thermal washer, and then just the use of heat. And as I stated, these are used when needing to reuse medical devices, such as those devices I was speaking of through surgery. So, a little bit different than disinfection, but they all have the same end goal, to get rid of the microbes on things. So this is a list of things that are least resistant to control measures. That would be your most of the gram-negative bacteria, fungi, non-enveloped and enveloped viruses, and also most of your gram-positive bacteria. It's not all of them, but most of them. And then this is a list of types that are most resistant to control measures. And we have our prions, our bacterial endospores, mycobacteria, cysts of protozoa, and trophozoites. So, microbicidal. This is a drug, a chemical, or any other substance that is used to kill microorganisms, given that suffix cidal. Cidal means to kill. So this we want to completely get rid of it. It will kill it out. It will not come back. Some examples of this would be antibiotics such as your penicillin or fluoxetine, um, your antiseptics, chlorine and iodine, and then some disinfectants would be acidified bleach and also regular bleach. Microbistatic, this is used to kind of just inhibit that microbial growth. It won't completely kill it, but it will stop it. Um, some examples of these is some of your antivirals, acyclovir and valacyclovir, your antifungals, meconazole and ketoconazole, and your antiparasitics, such as metronidazole and tenazole. So like I said, cidal means to kill, static means to inhibit that growth. So your physical and chemical agents that want to stop that bacteria or whatever is invading, um, they mainly target the cell wall, which causes the cell to become fragile and it will lyse. And I have examples on here for you. And then we have the cell membrane. This is where that cell will lose its integrity. Um, it prevents the replication, transcription, and translation by messing kind of with that protein nucleic acid synthesis. and then it will disrupt or denature proteins. Next, we'll talk about the moist heat method. So this is where they kind of want to go in and they destroy that microorganism by irreversible coagulation and denaturation of enzymes and structural proteins. The temperatures with this will range anywhere from 65 to 80 degrees Celsius, and that temperature is maintained for 15 to 30 minutes to ensure that microbial death occurs. Some examples of this is like boiling, pasteurization, or that autoclave we talked about earlier. And next you have the dry heat method. And this is the method where hot air that is free of water vapors is used. And the temperatures of this range from 160 to 170 degrees Celsius. This is typically maintained for 2 to 4 hours, so a little bit longer than the moist heat method. Some examples of this are the hot air ovens, incinerators, or radiation. So we'll talk a little bit about that thermal death time, and this is used to determine the length of time and the temperature that it takes to kill a specific type of bacteria. It was originally developed for the process of canning foods, but now they use this in cosmetics and to help produce salmonella-free feeds for animals. The temperatures in this is hot, um, anywhere from 1350 to 1450 degrees Fahrenheit. The time will differ for each microbe because that time is different for each. Some may take 3 minutes or some take 5. We'll talk about that here. That's that thermal death point. And it's the lowest temperature at which all microbes are killed in a 10-minute exposure. So as we stated before, different microorganisms respond differently to high temperatures. They're prepared in a broth, and like I said, it could take 3 minutes for this microbe where it takes 4 minutes for the next microbe. It just really depends on the type of microorganism you're dealing with. Now, we talked about the heat measures, so we'll jump into this cold treatment and desiccation. So with a cold treatment, you can think of refrigerating food. So this kind of slows the growth of any bacteria. Um, the freezing point can actually kill or injure these bacteria cells, and ice crystals can actually rupture that cell membrane and cause cell death. So this is, like I said, when you're refrigerating food or putting your meats in the freezer to kind of keep them from spoiling or going bad. Desiccation is the state of extreme dryness. In other words, dehydration. So it's really not the ideal environment for a microbe, but we'll kind of jump into that in a little bit. So there are some disadvantages to the advantages of the cold treatment. It does slow the growth of most microbes, and it kind of brings that cell to a standstill, and it can cause the death of the cell due to it not being able to withstand that cold environment. But this is only considered microbistatic. As we said earlier, cytal is to kill and static is to inhibit growth. So some cells can survive up to several months under cold conditions. And last, we have desiccation, which we said was dehydration. Microorganisms cannot grow and divide in this. This is used to preserve foods like making jerky, and it works because cells require water for growth. But these microbes can survive for long periods of time, but after regaining the water, they can grow once again, and this does not provide complete sterilization.